All right, so the power transmission team, and this is going to be our next prototype design. All right, so we got kind of lucky. We found a motor that was a 3/4 horsepower with a gearbox already attached. So that was the biggest cost for us. We're trying to figure out how to get that. With the gearbox on top of there, we're able to get 11 RPMs off of it. Either one of those could have just been the entire cost of the whole project. So we really lucked out there. It's got a, I think, 2830 torque transfer. So should be enough torque for at least doing some preliminary tests and then allowing for iterations later for other teams. Our design's pretty simple because we don't need to do a whole lot of gear reduction. We're just going to do the same size sprocket off up on a one shaft so that there's no RPM change. We've also got a VFD, or variable frequency drive, off of this guy that we can go from 0 to max. So we're going to be able to go from 0 to 11 RPMs. So if somebody needs to test lower RPMs, we're going to be able to do that. But this design's pretty simple. We used metal for our SolidWorks, but we're just going to use wood, cheap 2x4s, keep it as cheap as possible. We're going to put the motor on a pallet. The whole idea of having it a little bit wider is that we could stand here if we need to and stand on the pallet if we need to, or put weights on there to make sure that there's not a lot of shaking going on. Yeah, so single shaft, 2 bearings. We had to switch from 2 motors from our financial cost. What we're going to do is just and we can make 2 frames if we need to, if the extrusion team and the mixer team aren't going to be having the same height of the shaft. But what we'll do is we'll basically put the extrusion team on here, run their tests for whatever RPMs they need between 0 and 11, pull them off, and then put the mixer team on over here afterwards. Yeah, so that's kind of the plan there. With that validation plan of being able to run through those RPMs into those different extrusion team and the mixing team, we're going to be able to basically check off all these boxes. So we're confirming torque calculations, performance, validating motor RPMs and converter RPMs to other subsystems. We'll be able to give a little more specifications on shaft dimensions to see how the torque does on all the different shafts for the different teams. And we're also going to have to be considering coupling if we're not going to have all the same diameter shaft now that we got a square. So that's going to be something we'll have to think about. If maybe, I don't know, we'll have to figure that out. So, but we get determining power delivery system, finalizing the bill of materials. With that, the cheapest we could get it is probably around $250. The most expensive it's going to be, though, if we can't find everything we need. We'll have to buy everything off online. It's going to be about $350, $370. So the big cost is going to be the bearings and the pillow mounts for the bearings and the sprockets. Those are the 3 big costs. Everything else is pretty cheap. So yeah. And then our problems, yeah. So one of the things we ran into, we actually kind of are working on solving this right now. We might be able to go to the 406 lab to actually run the tests. Yeah, but the big thing was having to find 480 volts for our motor. And we found a couple different rooms. The 406 lab does have the 480 volt option where they can tie in. Rob Lentz might help us out with actually coming up with a plug-in or a system where we have a on-off switch, because we're only going to be running for a couple hours. So he doesn't want us sitting somewhere for days. And we don't want to have it on for days, so we want to have an on-off switch. So that's kind of what we've been working on, trying to figure out. But we're moving along pretty well. So, any questions?
With the 40 volt, talk to JB.
Yeah, that's a good idea too. That's a great idea. Go talk to he runs the engineering the machine shop.
Metal shop down the road.
Yeah.
There's a lot of welders in there, so you could have the
in the
plug-in for that.
2 buildings down. Yeah. That's a good idea.
Yeah, we toured a few options with Robert Lentz. He took us like 5 places.
But we talked to 406, and they said yeah.
Yeah, I emailed 406 professor, the coordinator for it, and we're allowed in there.
As far as like turning the square shaft, like do you think you could maybe just like bolt like a sprocket right on the end of it?
Yeah, we could do that. Put a plate, test the sprocket, and then have the plate attached to that. There's ways around it. Because it's wood, we can, hammer it. We could even put in like I was thinking just hammering a shallow, like a hollow tube, bam, bam, and then put a coupling on that. that could work too. Or if it can slide into our 1-inch diameter shaft and then put a coupling. I don't know. But yeah, a couple of ideas.
So with your that frame that you have in the middle that you're using to transfer from the motor to the
Yeah.
different devices,
Mm-hmm.
Can't we just, and this is throwing out there, I don't know all of your constraints you're working with,
Yeah.
but can't we just take the chain from the motor shaft and connect that right up to the different people's
Yeah.
devices?
Well, I mean, that was kind of what we had talked about originally, but we didn't want to come in with a plan being like, oh, we'll just have a chain.
We didn't want to have a shaft.
Oh, I see.
Yeah.
So,
We didn't want to have
I
a
think
shaft
we get
floating
it.
in midair.
Yeah, make sure that we get the points for the working on the project, but that is obviously the cheapest way to do that. So,
It's a bummer how education gets in the way of good design.
yeah.
Yeah.
So yeah, then all we would need is this same 16-inch or 16-tooth sprocket and a chain, and we'd be done.
Okay.
And you give us a shaft, and we're done. So,
Okay. All right. Yes, that sounds like a great idea.
yeah.
All right. Understood.
Okay.